So this is the post-lab over discovering density, folks, and I have made a example of the calculations you did using this graph right here. So the black dots up here represent gold. The white ones represented the silver. So what I need to do is I use this best fit line, okay? I use this best fit line to determine the slope. And the slope is y2 minus y1 all over x2 minus x1. Now, just some certain things here, folks. If I'm using my x2 and my y2, I'm using the higher value on the table, okay, on the graph. If I'm using my x1 and y1, I'm using the lower one. Also, some things I saw people that had the y's on the bottom, the x's on the top, okay? That's not going to get it done, folks, because you're going to be inverted, okay? You're going to be inverted in your data collection and your results. So basically, I look at my graph, and I had two spots I'm going to use. Right here is the first spot. I'm going to have this one be my x2, y2, and then I'm going to come over to this spot, and this is going to be my x1, y1. We want to usually get dots or places that are on the line. If you didn't have anything on your best fit line, any of your data points, that's fine. We can still read that best fit line. So when I look at this one right here, the very first one, I have my x value is 5.0, my y value is 38.0. My second data point was 8.0 and 64.0. So when I'm doing my x's and my y's, my y2 is right there, 64.0. My y1 is 38. So I'm going to take 64.0, subtract 38.0. When I do so, my sig figs should be in the 10th position, right? Okay. My x2 is 8.0. My y2 is 5.0. So when I divide that by those values, I should have that in the 10th place also. So when I did my math and had the sig figs to two significant digits, I came up with a value of 8.7 grams per milliliter. Any questions how I figured out my slope? All right, good. Now, what metal is this? We used that slope to determine what we had metal-wise. So I put this data table on there. If you remember, my value was 8.7 grams per milliliter. I have, first of all, I want to check this is grams per cubic centimeter, but that's okay, right? Because I know a milliliter is equal to a cubic centimeter. So I'm fine with that. I rule this one out. Nope. Might be, nope, nope. So I'm going to look at these and determine which one I'm closer to. 8.7, 8.57 is only 0.13 away, and the other one's going to be 0.22 away. So I'm going to say no on the copper that I am dealing, ladies and gentlemen. My metal that I am dealing with was brass. The next thing that we had to do was we had to calculate the percent air, because we wanted to see how accurate we were in determining this. So I look and I say, okay, my percent air is going to be my experimental value of 8.7. My theoretical value is what I just got off of that chart. I'm going to divide that by my theoretical value, which is the 8.57. Then I multiply by 100. So when I do my math up at the top, the subtraction, where am I going to round it to? Where am I going to round it to, Hannah? I can't hear you. The 10th, excellent, because I can look and I can see my values. Here's at the 100th, here's at the 10th, so I'm going to round that at the 10th. So when I did my math there, I came up with a 0.13. 0.13 has to be rounded to the 10th, so how am I going to round that one, Paige? 0.1, excellent. So with sig figs, I'm going to have that at 0.1. So my 0.1, then I am going to divide by my theoretical value once again, multiplied by 100. Remember that this 100 is an exact number, so I do not use exact numbers. We talked about exact numbers yesterday, didn't we? Okay. I don't use an exact number because there's no uncertainty in it. Okay, there's no estimated value. I know I'm multiplying by 100. So when I do my math, I came up with a value of 1.1668614. Okay, Amelia, how many sig figs do I need for that number? Just one. And I got that by right here. Here's 1. I'm dividing. Here's 3. What's lower between 1 and 3? 1. So when I round this to one significant figure, my percent error is 1%. Any questions for me over this post lab?